Now, what I want to do, I'm not going to solve this one yet. Can I borrow your book? There was one question that you were doing. It's that one. Yeah. Right, I'm going to just talk to you about another way of doing these simultaneous equations. So, remind me again, please, everyone. No one should be writing at the moment. Okay? Remind me what you are doing when you are solving simultaneous equations. Yeah.
Finding out what the value of usually it's x and y, so it's usually finding the value of what x and y is.
But I want to be more specific. What's the value of x and y? We are trying to find it, but what are they?
Finding these commonalities between.
Don't overcomplicate it. What do I know about x and y?
They're the same.
They're the same, yeah? Is that what you were going to say, Melissa?
Yes.
What were you going to say in full? You were going to say that, yeah? So we know that the x and the y values for both equations are the same values. So we are looking for those two values that work for both equations. So that's what we have to keep in mind. So if I were to look at two equations like this, I've got x equals 5y minus 1, okay? And my second equation is x equals 3 minus 5y. Simultaneous equations. They're in a slightly different rearrangement than you're used to seeing. Now, could I do a subtraction method? Yeah. Can I do a subtraction method without multiplying? Why?
Well, I don't want to say move it, but like you just rearrange it so that it's.
Do I need to rearrange it though?
No. Well, you don't need to, but like.
Have I got a variable that's the same in both equations?
Yes.
What?
5y.
Well, I've got 5y. One's positive, one's negative. But I've also got x's that are the same. Now that's the thing. By putting x on this side on its own, suddenly it just, I don't know, you don't consider it anymore. Alright? I could rewrite this, like you say, as x is 5y minus 1. And x is minus 5y plus 3.
Oh.
Yeah?
Confused.
That was a very quick confused.
I was yawning when I said it.
Yes.
Could you say that 5y minus 1 equals 3 minus 5y?
Okay, great. Right, that's what I was going to talk about. We could, now, what would you do? Subtract or add, or either? Well, if I add them, what do I end up with?
No, we can use 5.
What do I, if I add them in total, what do I end up with? 2x's equals 2. Yeah? Got that?
No, I'm sorry.
5y add minus 5y is
Yeah.
0. No y's, it's gone.
And then
Minus 1 add 3.
2.
2.
Oh, I'm sorry.
Exactly what we've done before. Now I think a lot of you have this block. Oh, it looks different to it usually looks. Therefore, let's forget everything I've ever learned about anything ever, and let's pretend it's something completely new, and then I can say I don't know how to do it.
No, it just wasn't lined up, so I wasn't.
No, exactly. It's not lined up. And how?
No, she didn't mean that. She means the 2.
So I
No, I
thought
do. I know what it means.
Minus 5 equaled 2, and I was like, how did
Yeah, I saw that too.
Yeah, no, I know. But it's about understanding what the. Should I have to actually line things up? Anyway, we've got 2x equals 2. Before you got a question?
Yeah.
What?
Could you just do minus 5y plus 3 equals 5y?
Well, Megan's already said that. You're jumping on her bandwagon. I'm going to do it in a minute. I'm just going to add to what we have been doing. What if I subtract instead of add? What would I end up with? So this would end up being
0?
right, 0. And now I have to write the 0 because there's nothing else on that side. It has to be 0. But what would be on this side? 5y subtract minus 5y would be? 10y.
5.
5 subtract minus 5
0.
would be 10.
Oh.
Minus 1 subtract 3.
1.
You were right. Now, so I'm in a slightly different position.
That's what I thought.
Right? Slightly different position here, but I could still now solve this. What would I do to solve this?
Add 4.
Add 4, so I get 4 equals 10y. Then y is 4 divided by 10. Okay?
Are you minusing
Is that
the
the
bottom
same
from
for
the
you?
top one? I mean, or the top one.
Then I wrote it this way.
Right, so I did, for the subtraction,
I did.
1 subtract 2.
Is it usually 5y minus 5y?
No, it's 5y minus 5y.
Yeah, so isn't that usually? Oh, it's 10. Yeah, you're right.
Thanks. Right, now, okay? Now what a couple of you have just said, Megan and Jen have both just said. So I've got the elimination method. In this particular example, I could add or subtract, there is no multiplication needed. But actually, in this situation, it's now nice and simple to spot, and this is very useful for the other algebra stuff that you've been doing. That it's something that a lot of people don't see when they're working. But remember the substitution method. All right. We can use the substitution method, but people think, well, it's not substitution method because I'm not putting that in for the x. But actually, you are. So instead of using those two methods, I can actually say, well, the x, which is important, is the same for both. That x is equal to that x, which means the same x equals both of these things. Now, logically then, if x equals that and x equals that, we can also say that that equals that. So I can write that 5y minus 1 equals 3 minus 5y.
What?
Now I have what you've done since year 9. You now have a very simple linear equation with the same unknown on both sides. How do you deal with it? I would add 5y to both sides, giving me 10y minus 1 is 3. I'd add 1 to both sides to give me 10y equals 4. And look, I'm there, same place. Alright? Shh, listen to yourselves. Got one person asking a good question, the rest of you just are not listening. Go on, what was your question?
Oh, it's a
You started with how. So, no?
She said, how do you get the name?
No, saying how they
Right, what this is called is equating the two expressions. Okay? Do you know what equating means? Making equal, yeah. You are stating that they're equal. And it's that jump. Now, have I substituted? Well, yes, I have. Because I've said x is equal to that. So I've just put that there.
And you did it with the other one too.
That's actually really cool.
Yeah? That's all I've done. So I've got to. Now, I guess what I wanted to look at, right, is when do you decide which one to use? Which method? So, for instance, if I've got 5x minus 2y equals 17, and I've got 3x minus y equals 9. Okay. Which method would you choose to use here? I wouldn't. You could, but I wouldn't. Which one would I use? I think here I would go for the elimination, and I'd multiply this one by 2. Yeah? Now I could, however, use any method I like. So I could rearrange this one and make it y equals 3x 9. Alright? Now I could substitute this. Okay? Now that could replace this y.
Oh my god, and
Right? I could also, what I want to know is, what if I wanted to equate the two sides? So I've got 5 minus 2y equals 17 again. Can I rearrange this one to make it y equals?
No.
Well, I can.
Actually can because he lives out of it.
So what would we do to do that? So can I add the 2y first? I'm going to do that because to get rid of the negative, so I've got 5x equals 17, add 2y. I'm then going to minus the 17. You might think that's overly complicated, but
that's what
it keeps it. Yeah, well, that's great. I've got that. Exactly. Now I divide by 2. So I've got 5x minus 17 over 2 equals 1. Now, both of them, so equation 1 is now looking like that. Equation 2 is looking like that. Can I do equating the two sides?
Yes.
And what would I write?
5x minus 17 divided by 2 equals 3x minus 9.
And to make it easier, you can just times 2.
Okay, great. So now at this stage, now I have to solve for x. So I times by 2 on both sides. I get 5x minus 17 equals, are you happy if I just do it?
6x
Go on,
minus
6x
18.
minus 18. Okay. I'm not going to go any further because you can see, you know what happens from that point. That you just keep eliminating things. Now, what you've got then.
That was my fault.
Took a while before she turned around.
Oh, I wasn't saying anything. I was
No, I know you weren't looking. You're not going to get it.
Because you just finished.
No, I haven't. What I was saying was that for simultaneous equations, you have these 3 possible options. Now, which way would you use? Well, depends what you have been given in the first place makes it easier and the most efficient and effective. You have to use one way rather than the other. You will be expected at times to do this, to equate. Now what I want you to understand and to realise, which a lot of people, we don't do this, we don't link all these things together, is this is still simultaneous equations, right? One's sharing the same x value, right? Simultaneous equations, equating the two expressions, right? So when we do assessments on simultaneous equations, and we have to go on to forming and solving them, use whichever method you like. Right, so for your test, I just want to tell you, tomorrow, be there, sharp, ready to go. The test gets done. If you're late, you're late. Right? Mentally, your focus is on improving on those ungraded assessments. That's really it for me. Right? Obviously, you would like to score a good grade, but it's about showing me how you've progressed on the things that you couldn't do before. That should be the focus, not on the grade. Although you will focus on the grade.
So the question is, I really want to do my
Okay, have a good rest of the afternoon.